Chemistry Lessons, Periodic Table, and Periodicity. Here's an example of a periodic table. As you can see, it is laid out in columns, which are the tall ones. Here's a column, here's a column, okay, column, and it's laid out in rows, okay, like this. These numbers over here, row 1, row 2, row 3, 4, those rows are also known as energy levels. And every one of those rows means there is another energy level of electrons outside of the front ones that are inside. Thus, everything in row 1 has one energy level. So it would look like with a nucleus here, and then it would have one energy level of electrons. If it was in the second row, then it would have two energy levels. And if it was in the third row, it would have three energy levels, and thus all the way down to where the maximum amount is 7. This is what the periodic table really looks like. We take these elements here, which are known as the lanthanides and actinides, and we normally set them down here underneath it. We do this so it will fit inside a book because this makes it very long. But this here is a basic family, and this is a basic family, and these guys here all have similar properties about them, which makes them a basic family. Okay? This is an example of what the periodic table looks like that we use in class. This is the one you will be getting for tests. It also has everything laid in rows and columns, and as you can see now, we have taken and pulled these out and set down here below. That's what these little symbols here mean on the periodic table, the little star and the little, T sign or plus sign, whatever that symbol is there, because it means that this row here fits in between this block starts and this one here goes. That's why you see that goes from 57. If I erase those little marks right there, we can see that this goes from 57 to 72. And if we look down here, we can see that here's 58 and there's 71. So this entire row right here fits right in there and makes it look like that table that we were just looking at. Columns are known as families. So whenever we have a column, we usually have a name for it. Column 1, column 2. Column 1 is known as the alkaline metals. Column 2 is known as the alkaline earth metals. Over here, as you can see, is listed as the halogen family. And then they usually will name the top element, like oxygen. This would be the oxygen family down here. The nitrogen family down here. And they all have similar characteristics, and that's the reason why they are grouped that way. It's the way nature has laid it out. Now the rows, as we just talked about a minute ago, each one of these rows here, row 1, row 2, row 3, all the way down to the bottom, which is row 7, these rows are energy levels. And as I told you just a minute ago, if we took a look at the nucleus of an atom, then these two elements up here, hydrogen and helium, would only have one energy level. They only have one row. That's why the maximum that they can hold inside there is 2 electrons. Then if we was to look down at the next row, the second row, they add another level, and there they can add up another 8 electrons, because as you can see, there is 1, 2, 3, 4, 5, 6, 7, 8. So that's why, neon here ends in 10, that's 10 protons and 10 electrons in a neutral or zero charged element. Every time we add a row, we add another energy level, and we can start to add more electrons. Okay. Now this gets quite, involved down here at the bottom, because instead of just 8, which I can add here, I can then start adding these 10, so that means I can add 18, and if I get down into the 4th and 5th row, I can start to add these also, which fit in here, and then I can start adding a whole bunch more electrons. But for right now, you just need to make sure you understand that every row is an energy level. Now, they call it periodicity because the way the elements are laid out on the periodic table, they all have similar properties. And electron affinity, affinity meaning a love of, means that they have a love for their electrons. And things that have a high electron affinity, or love of their electrons, do not get rid of their electrons very easily because they love them so much. These guys usually form what we call anions. And they are all found up in this area of the periodic table up in here, because the highest electroaffinity element or electronegative element is fluorine right here. It is the most peak one, okay? So, all we're saying here is that this is the way it works. Ionization energy. It doesn't take hardly any energy at all to make an ion out of francium. But as I go up the periodic table, on each one of these deals, as I go up a specific family, it becomes harder and harder to remove an electron. And it's mostly because I am now sitting closer, this electron, if I look at it here and I'm sitting way out here, the further out an electron gets from the nucleus, then the less pull this proton has on that electron. So it's easier to remove. Francium has 7 energy levels, so there's 7 layers of electrons out here. Very easy to remove an electron off of francium. If we look at lithium, it only has how many? 1, 2. It only has 2, so we'll draw it over in this corner. So we got a nucleus, and then we have 2 energy levels, and it only has 1 electron in that outer energy level. As you can see, only 1, because it's in column 1 here. So it is very hard, or more difficult, for it to pull that electron away from this proton that's sitting here saying, hey, we're going to keep you here. I want you in here, okay? So when you look at this, the way this trend is of the periodic table, that's what we talk about with periodicity. This also happens in size and also in ionization, okay? So every one of these elements on the periodic table can form an ion. Okay? Every one of them can. It just depends on how much energy it takes to either pull the electron to it, and these guys up here are all the ones that pull the electrons to it, and if they add an electron, they become negative. And if they become negative, we call those anions, because they form negative charge. Everything in this column here forms a -1 charge. Things in this column here form a -2 charge. And thus, everything from this stair step right here, which is a metallic boundary, which we'll talk at a different lesson. So everything from this stair step right here, all of these elements over here are called metals. All of these are called metals. All metals form cations. And a cation means it loses its electrons. So it now has more protons than it does electrons, okay? Because it loses these guys. It's going to give them up so its outer energy level is full. And remember what we talked about in class. Every element wants to feel like a noble gas because its outer energy level is full and it feels happy. In nature that way. Now, as you can see on this periodic table, this is a periodic table, but all we're talking about right now is atomic size. Okay? And remember, this word right here, atom. When you see the word atom, it means no charge. Same number of protons as electrons. So protons equal electrons. Okay? So there is no overall charge. Now you can see a very specific trend going on here. The more energy levels, the bigger the size. The size of hydrogen as compared to cesium down here at the bottom on row 6. Excuse me. The same thing over here. As I move across the periodic table this way, I increase my atomic number, thus I increase the amount of protons. The more protons I have pulling on those outer electrons pulls them into the nucleus and makes my size smaller. Even though I have more protons and more electrons, I am going to be holding them tighter and tighter to my nucleus there, my nuclear pole, and thus making the size of me that much, more tighter, more small. Okay? So as you can see, the general trend is if we go down the periodic table, we're going to get larger. If we go across the periodic table here, we're going to get smaller. And it all has to do with the same energy level, but more protons pulling on those electrons in that energy. Take a look now at ions. Ions means we've either gained, we've added an electron, and the ones that add electrons are over here, okay? Or we've lost an electron. And if we've lost an electron, we're over here. So let's take a look here at hydrogen. As you can see, when hydrogen is just itself, neutral charge, same number of protons as electrons, it has a fairly small size. But when it loses that electron, it increases in size because it doesn't have that counter ability, okay? Excuse me again. All right, let's look over here at francium. Francium gained an electron, got bigger. Chlorine gained an electron, got bigger. Sulfur gained 2 electrons, got bigger. Phosphorus gained 3 electrons, got bigger. Whereas their atoms all are similar in this direction. Okay? So when you're looking at atomic size in ions, you need to make sure whether it's going to be either an anion is going to increase in size, or is it going to be a cation? And a cation will actually lose electrons and get smaller in size. Okay? Here's basic concepts that we were just talking about. Periodicity is a very complex concept, and we cover it tremendously in depth in AP chemistry or in college chemistry. However, it is very easy to understand for you in general chemistry. Just remember, you can look at electron affinity. Affinity is love of electrons. As we move across the periodic table all the way over here to fluorine, becomes the one that has the highest electron affinity. Will not get rid of its electrons. Will gather electrons to it. Thus why that ties to atomic radius, okay? Atomic radius is going to decrease in this direction because this guy here has got, one energy level and loves its electrons so much, it's pulling them into its nucleus, okay? Then if we look over here, we can see how things increase in size due to the number of energy levels it has, and will decrease in how much energy it takes to get rid of that electron, because remember, more energy levels down here at the bottom means it's further away from the nucleus, means it's easier to actually take that electron from it, means it's easier to become an ion. Okay, I expect you to review this lesson as much as you feel you need to get this basic concept down, and please, as always, ask questions in class if you need to. Come in and get help. Remember, as always, chem is try, okay? Chem is try. You have to continue to work. You cannot get up. It doesn't matter how difficult this is. Never, never, never give up. And as always, stay gritty out there.